In this video, we will discuss data operations in Pandas. In the previous lecture, we talked about selection and indexing. And selection and indexing are useful if we want to select a subset of the data frame or the series we have at hand. Many often we want to operate on the values. More specifically, we want to operate using some mathematical operations. We've seen one of these operations, for instance. If we want to calculate the density in a state, we want to divide the population over the area of that state. Now, when we have two single values in Python, those mathematical operations are built in. So we can add two numbers, we can divide two numbers, and that works fine. Those operations on Python, they don't extend to sequence of values. For instance, you can do 1 plus 2 and you will get 3. And you can do 1 minus 2 and you get minus 1. However, if you do 1, 2 minus, for instance, 2, 2, you're not going to get minus 1 and 0. This operation is not supported on a list. However, many often we want to support such operations on list, vectors, two-dimensional data structures such as matrices or data frames. And that's where packages like Pandas and NumPy fill in this gap. Basically, they provide a bunch of functions, and those functions are called universal functions because those universal functions can operate on single values, sequences of values, a unidimensional sequence of value, and also a two-dimensional set of values such as a matrix or a data frame. The book goes in detail about those universal functions, and basically those functions are inherited from NumPy, and Pandas extend upon these functions. We're now not going to go into the details of these functions. We need to understand three important concepts in order to know how they operate. First, we need to understand the concept of a universal function. Second, we need to understand alignment. And then third, broadcasting. So first, let's take a look at what a universal function is. In this example here, I'm creating a series and also a data frame. Now, let's take a look at one function which is provided by NumPy, which is to raise a certain number to the exponent of a certain number, so 2.7 to the power of that number. Okay, so 2.7, for instance, to the power of 2, that's basically 7.38. This function is called exp. It's used widely in quantitative applications. It's not very useful for data analytics in many applications, but that's an example of a universal function. np.exp2, that's basically the same value here. Now, what if I want to raise, for instance, 2 to the to the power of 2, 3, and 4? We cannot do this in built-in Python because the power function in Python doesn't take a list, it only takes floats. So that doesn't work here. However, this function, exp, is a universal function, meaning it can operate on both single values and sequence of values. It can also operate on two-dimensional structures. So for instance, if I have a matrix of value, this function can also raise each value to that exponent. So it can operate on a series. It can also operate on a data frame. And there are many of these functions in NumPy and in Pandas. So for instance, we have an example here of the functions sine, which is also a universal function. Those two functions, the exp function and the sine function, they take one operand. For instance, just takes one value. Now, the universal function that takes one operand is the easiest to understand, because if you provide a sequence of values, it's going to apply the same function on each one of the value. If you provide a matrix of values, such as what we have in this data frame, it's basically going to apply the same function, the exp, on each one of these values. But obviously not all functions take one operand. Most of the functions we use take multiple operands. For instance, plus we need to add two things, minus we need to subtract one thing from another, and so on and so forth. What happens if a function, a universal function, takes multiple operands? Well, there are two things that happen under the hood, and those two things are very important to understand how those functions behave. Those two concepts are called broadcasting and alignment. What is broadcasting? Broadcasting is simply repeating the same operation over multiple values. So let's take a look at the series here. This series has multiple numbers, 6, 3, 7, and 4. If I use the function plus, which is the function add, and add 1 to the series, this universal function plus is going to broadcast the operation plus 1 over each one of these values. It means adding 1 to each one of the values separately. Now it's very crucial to understand that this is not the built-in plus function in Python. Python will interpret this as the add function in the series. This is equivalent to saying series.add1. And series.add1 is a universal function that does broadcasting and index alignment. Of course, we don't worry about these functions because they have the equivalent syntax representation here, which is a very quality of life feature here. Unlike Java, we don't need to call these functions specifically. We can overload these operators. So that's very important because those are the built-in function. They're not the built-in function in Python. Those are the Pandas functions, and those are universal functions. Okay, so what is broadcasting? Broadcasting simply is when the dimension of the two operands are not the same, the operation will be broadcasted from the operand that has the lowest dimension to the operand that has the higher dimension. So the series has a dimension of 1. A single value doesn't have any dimension. It's a 0 dimension. It's a single value. Hence, this operation is going to broadcast it over the series, meaning each value on the series, it will be the value plus 1. That's broadcasting. Okay, let's take a look at our data frame here. Our data frame here has 2 dimensions. If I do plus 1 here, this was going to be broadcasted over the 2 dimensions in this data frame, meaning I will get each number in this data frame plus 1 as a result. This universal function adding is broadcasting this over the two-dimensional data frame. That's the very important concept, and we will get back to it when we will be operating and adding a data frame to a series. But before doing so, let's talk about index alignment. Index alignment is basically when you have an operation and the two operands are series and or data frames. In this case, what Pandas does, it basically aligns the indices in order to perform the operation on the values in which the indices match. Okay, what does that mean? I'm going just to give you a quick example and then we go and see the more detailed example. Let's take a look at our series here. Okay, so that's our series. Now, if you do series minus series, what happens here is that Pandas will align the index so that you subtract each value from the corresponding value that is associated with the same index. Obviously, this is a trivial example here, and you will get zeros all over the way. But let's take a look at series here and let's reverse it. Let's reverse series here. I'm actually going to use the built-in function, the built-in indexing. I'm just going to indexing with a step of -1. Okay, so let's do series 2 here is equal to that, and that's series 2. Now the question to you is, what's the value of series 1, which is series minus series 2? Now, if Pandas is doing the operation by order, it's going to subtract 4 from 6 and you will get 2, and 7 from 3 and you get 4, and 3 from 7 and you get -4, and then, sorry, 4 minus 6 and you will get -2. But that is not what it does. It basically realigns these values based on the index. It's going to match this one with this one and then broadcast the minus operation. It's going to match this one with this one and then broadcast the minus operation, so on and so forth. Let's take a look at this example here. In this example, we have two series. One is called area and one is called population. And you can see that the indices do not match here. We have areas of Alaska, Texas, and California, but population for California, Texas, and New York. Say I want to calculate the density, population divided over area. What do I get? Well, Pandas is going to align the indices. It's going to align Alaska with Alaska here. Well, guess what? Alaska here doesn't exist, so we get a null value or NaN. We will look at missing values in 2 lectures from now, but you can see that as the result of aligning the index is doing the meaningful operation, because the meaningless operation is to divide the population of the first state over the area of the first state, and you get a meaningless value, which is the population of California divided over the area of Alaska, and we don't want that to happen. Thankfully, index alignment does the right job, which is aligning the index before broadcasting the operation. Now, California exists in both series, hence you get the result of dividing the population of California over the area of California, and the same thing happens for Texas. New York, again, it does not exist in the area data frame, hence it has an area of missing or null value, and you get a null value as a result. The alignment of the index is happening under the hood, and as a result you get a series which contains the union of the 2 indices. And the values of these indices that do not match were going to be populated with null values. Now, if you don't want these null values, if you want to, for instance, if you want to add 2 series, but if something doesn't exist on one, you want to consider it to be 0. In this case, you can call the function add and provide an optional parameter fill value equals to 0. Instead of getting the null values here, you will get only the values in the other series. Let's talk about index alignment in a data frame. In a data frame, it has the 2 axes, columns and indices, and hence Pandas will try to align both the row index and the column index. Let's take a look at this example. We have a data frame A that has 2 rows and 2 columns, row 0, row 1, and columns A and B. And this second data frame has 3 rows, 0, 1, 2, and columns A and B and C. Okay, so what do we get if we add A plus B? Well, it's going to align, right? So it's going to align both columns and both rows. So in the resulting data frame, we'll have the union of all of the columns A, B, C, and all of the rows 0, 1, 2. However, we will not see any value here. Although these values exist for B, they're non-existent for A, and hence it will be null values here, and null value plus any value will be a null value. Now, obviously we can improve on this, and this is something we will get back to it. We can use the function add, and we provide another fill value, and this value can be the mean of the frame, or 0, or anything we would like to kind of to impute this value. So those are some of the universal Pandas functions, and they overload the existing Python operator. So unless we want to provide an optional parameter, we can use the Python operator here, plus, minus, multiply, divide, floor division, mod, and power. If we want to provide optional parameters, we can use the Pandas function. Now we go to the most challenging operation, which is combining a data frame with a series. But honestly, it's not very challenging once you understand the concept. It's basically aligning and broadcasting, except that the series is a unidimensional data structure and the data frame is a 2-dimensional data structure. So what we're doing, we're aligning the index of the series with the index of the data frame, and we are broadcasting across the columns. Let's take a look at this example here. This is our data frame. Let's call this data frame df. I'm going to break this into multiple operations. This is df, and this is df.ilog0. And as you can see here, df.ilog0 is 1 row in the data frame. Now, if I do df minus df.ilog0, what Pandas is going to do is going to align the index of the data frame, and is going to align it with the index of, the index of the series, and align it with the index of the data frame. Well, guess what? The data frame has two axes. So is it going to align it with the row index or the column index? Hence again, Pandas is making a default choice for us. By default, it's going to align it with the column index, but this is something we can override. If we don't override it, it's going to align this series with the column index. Once it aligns it, it's going to broadcast the operation. So we're going to have 3 minus 3, 8 minus 8, 2 minus 2, and 4 minus 4. So we'll get first row being all zeros. For the second row, we will get 2 minus 3, which is the minus 1, 6 minus 8, which is the minus 2, 4 minus 2, 2, and 8 minus 4, which is 4. If we want to do the opposite, which is aligning with the row axis, we need to use the function subtract. We need to say instead of minus, subtract, and we need to provide the optional argument parameter axis 0. In Pandas terminologies, the row axis is the 0 axis and the column axis is the axis number 1. So in this example, if I subtract df from dfr, now don't forget that dfr is a column, so that's df, and this is dfr. If I want to subtract column wise, so I want to align with the row axis, I need to use the function subtract, and I need to set my axis to be 0. Or rows. So again, axis 0 is rows and axis 1 is columns. The other option, if I don't want to use the subtract function, I can use dfr here, but because by default the minus operation operates on the column axis, it will not work because 0 and 1 are not on the column axis, right? So I get null number. There is no overlap whatsoever between my column axis and the index of the series, which is 0 and 1. I need just to flip my data frame, take the transpose, and then this will then align well because now the column axis is a row axis and vice versa. So minus dfr is going to align here, and then I can retranspose this again. That is if I don't want to use the dot subtract function. Again, the default decision that Pandas has done here is to basically say that operations are more useful when they are these operations row-wise, meaning I want to align the column axis. Let's take a look at this last example. In this last example, we're taking half a row from our data frame df. So half a row, which is the first row, and I'm getting each other column. So in the beginning to the end with a step of 2. So I get Q and S. So in this case, if my data frame is this one, Q and S are 3 and 2. Now, if I do df minus half row, I'm going to get this data frame because it's going to align on the column axis. So 3 and 2, 3 will align with this one. I'll get 0, 2 will align with this one with 0. There's no alignment with R, so I get a null value, no alignment with T. This one is 2 minus 3 minus 1, and 4 minus 2, which is 2. Now to conclude, in my personal usage of these operations, the most useful features I find whenever we do data analytics tasks is to operate on the columns, because the columns often in our data corresponds to variables. So very often, notwithstanding all of the nuances and the options that these operations provide, I usually end up simplifying my data operation process by pulling columns as series and operating on the series. It's much easier to understand what's going on when you have two operands that have the same dimensionality, like a series with a series minus a series, and so on and so forth. We're going to revisit these operations in more details in the future.